record this, the screen share, so let me try that again. Okay, so Ms. Burge's video that she made talked about the probability, like conditional probability, right? The probability of event B happening, given that you know event A happens, and there's this formula that she kind of worked out that you can use the probability of A and B happening divided by the probability of A happening. So if we looked at number 1, Andrea's a very good student. The probability that she studies and passes her math test is 17 out of 20. If the probability that Andrea studies is 15 out of 16, find the probability that she passes given that she has studied. So we're trying to find this, right? That's what we're trying to find. So that means that the probability of A is actually the probability that she studies, right? This is the probability, like A is the event that she studies. So keeping track of like what A and B are helps as well. So this is the probability that she passes given she studies is what we're trying to find, right? So then we need the probability that she does both A and B. And so that means that she studies and passes, right? Studies.
Would you multiply those two or add them?
This one?
Oh yeah, the A and B.
So the probability of A and B is actually going to be its own thing. Like if you look at the problem, it says the probability that she studies and passes is 17 out of 20. So like that one is the number that you put in for probability of A and B. That will be 17 over 20. Right,
oh.
Straight from the problem. For like the first couple of ones of these, like you have this probability of A and B, and you have probability of A like from the problem. So then you can set it up in this equation and solve. But then for some of the later problems, like I would say starting at like number 6 and down, you actually have to figure out how many possibilities, like what that probability is, and we can go through one of those after this problem. So this is the probability that she studies on the denominator, and that probability is 15 out of 16. So then we want to simplify this, right? Remember that when you divide a fraction, like this is just 17 over 20 divided by 15 over 16, and to calculate that, right, we just multiply by the reciprocal whenever you divide fractions. So 17 over 20 times 16 over 15, and then we can simplify before we multiply it out. I did that, it was like easier for me to multiply, and then you get 17 times 4 is the 68, 5 times 15 is 75. So that's why you can see like at the answer at the bottom, or on the back page, it says 68 over 75. So that's how that is calculated. Does that help?
Yeah, I was just using the formula wrong.
Mm-hmm.
Yeah, that's where I was having trouble there.
I'm glad you came on to ask about it. And yeah, I'm going to post, well, I don't know what this recording will look like. Hopefully it's recording what I did on the screen with you, so I can post that as well. But I will post what I have here with like everything, like my solutions anyway. I'm gonna do one where you have to like figure out the probabilities on your own in order to calculate this. So how about we look at I thought number 7 was kind of hard. I actually had to ask Ms. Burge to help me on that one. Do you want to look at that one? 7. Okay, so this was number 1. And I'll write that down. Number 7. So this is the problem where a family has two children, a family that has two children is selected at random, and we want to find the probability that both children are boys, given that there is a boy in this family. So I want to figure out what like P of A is, P of A and B is, in order for me to figure out probability of B given A, right? Because that's what we need for this like formula. So probability of B given A, that's that both of the boys, or sorry, both children are boys, given that there's already a boy in the family. So the probability of A is there's a boy in the family. A boy in a fam. So how can we figure out like what the probability of that is?
It's 1 and 2.
What Sebastian says, it's, what do you mean 1 and 2?
Is it not a 1 in 2 chance that one of the kids in the family is a boy?
Oh, so that is it's a half chance that like if you have a kid, like it's going to be a girl or boy, but it's saying with like two kid family, what's the probability that one of the two kids is a boy, right? So what are the possibilities? Like how can we come, like what are the possibilities of the two children's genders? It could be boy boy, right? Mm-hmm. A boy girl, a girl boy, and then a girl and a girl, right? Because like
so it's a 3 and 4 chance it's a boy.
Yes, exactly, right? Because like of the first kid could be a girl and the second kid's a boy. It's still a boy and a girl, but like it's different if it's a girl first versus a boy first.
And now it's asking like what are the chances if it's two boys? So then it's
exactly. So that's
so then it's like 3/4 like over.
So that would be in our denominator, right?
Okay.
For P of A and B. Sorry, I'm trying to write fast, so it's like messy. So in our denominator is 3/4. We still have to figure out the probability of A and B. So the probability of A and B would be that you have at least a boy in the family and, the probability of A and B is, at least there is a boy in the family, but like both of them are also boys. So how can we do that? There's only one way, right? This is the only way. Boy, boy. That's 1/4 probability. I don't want to like lose any of you there. So do you all understand why probability of A and B is only 1/4?
Yeah.
Caroline, yes. So that's because, right, that's the only way that we can have both of them be boys, but also still have a boy in the family, right? Well, like, there's only one way. So 1/4 will be in the numerator. And then when we simplify, 1/4 times 4/3, that's how we end up with 1/3. So for like I would say from 6 on, you have to actually figure out like the probability of A. You have to figure out the probability of A and B, and before you can actually figure out the final answer, right? Any problems on the back that you want me to go over? Like 9, 10, 11. I'm gonna tell you now, I have to skip 12. Ms. Bird and I were thinking about this, and she's gonna ask her daughter to help with that. So I just got stuck on number 12. Number 12 is hard, unless I don't know if any of you figured it out, but I will get back to you on that one. Do you want to just try it on your own now that I've done these, or do you want me to do another one? Anybody? There is one note I want to make for number, oh shoot. For number 9, I just want to note that 1 is not a prime number. So I kept getting this problem wrong because I was counting 1 as a prime number. 1 is not prime number. So your probabilities would be affected if you were using 1 as prime. Let's see. Yeah, I thought as long as, like, I don't know, I think the rest of these you could probably figure out now that you have that like formula that I went over. But like number 11, you do have to count out all of the methods. So I don't know, do you want to do that one together? Number 11.
Yeah, can we just go over it real quick?
Yeah, let's do number 11. So for number 11, we have, we're selecting a number randomly between 10 and 50. So how many total numbers are you looking at? Like how many possible numbers can you choose from 10 to 50?
40.
Close.
Wait. 42?
A little too many. 41. It's 41. That's just like, so because you do like 50 minus 10 plus 1 because you have to count like 10 as well. You can count them on your hands. It's a lot to count, but like it is 41. So that's number 1. You have to make sure you're using 41 as your total. There are 41 total like possible numbers that we're choosing from. So all of our probability denominators should be 41. Then I went through, like, I would say that the easiest way to go through these is to like distinguish your A's and then your A and B's, right? So how they're written, it's always written as probability of B given A. So you know that everything like on the right of that line is the probability, or is the A, like the event A. So I would say like probability of A for part A, that would be the probability where it's greater than, I'm actually going to erase that. Probability that the number is greater than 40. Right? What's the probability of that? How many numbers between 10 and 50 are greater than 40?
10.
10, right? We start with 41. 41, 2, 3, 4, all the way to 50. So there's 10. So that's 10 out of 41. For B, I just got all of these before I put them together because I don't know. I thought it was easier to do it this way. So now I'm going to say find the probability that the number's even. So literally like count through them, right? Like 10, 12, 14, and you go all the way up to 50. You should count 21 even numbers. I'm going to give you that one because that one's longer. So 21 out of 40, oops, 41. And then the probability that the number is between 20 and 40. So how many numbers are between 20 and 40? So this one is going to be 40 minus 20, but then we have to subtract 1 because we're not counting 20. So, or because we're not counting 20 or 40. So there's actually 19. And I actually went through counting all of these, so you can, do that as well to like verify. But I don't think there's like a fast way to figure that out other than like counting them all or like writing them out so you can see how many there are, right? So like 21 all the way to 39 gives us 19 numbers. And now I want to find the ands, right? So for A and B, the probability of A and B is actually the same because they're just like flip-flopped, right? For part A, it's like the B is even and then the A is like greater than 40, but for part B, it's flip-flopped. So the probability of A and B happening is actually the same number. So how many numbers are even and greater than 40? 42, 4, 6, 8, 50, right? So 5 numbers. Yeah, let's do that. 5 numbers. So the probability of A and B happening for these two is going to be 5 out of 41. We'll need that here as well. 5 out of 41. And then for part C, it's between 20 and 40, how many numbers are also prime? So I counted them. I went through. So 21's not, 22, 23, the first prime number, 4, 5, 6, 7, 8, 29, 30, 31, 32, 3, 4, 5, 6, 37, 38, 39. Wait, no, I messed something up. One of those wasn't prime. Between 20 and 40. So 20, I didn't write them down because I counted them out the first time and it was right. 21, 2, 23. 23 is the first one. I'm going to write this down this time. 23 is prime. 4, 5, 6, 7, 8, 29 is prime. 30, 31. 31 is prime. 2, 3, 4, 5, 6, 7. Is 37 prime? 37 is prime. 39 is not prime. That's the one. 37 is prime. 39 is 13 times 3. Right? Yeah, 13 times 3. So these are the only 4 prime numbers. So the probability of A and B for C. So that's like between 20 and 40, but also prime. There's only 4 of them. 4 to 41. So now we can put them all together. The probability of B and A. Okay. If I call the probability of B given A is going to be this one, right? 5 over 41, sorry, divided by 10 over 41. So we get 5 over 10, 1/2. And then did the same thing for the rest of these. Right, just put the probability of A and B over the probability of just A to get the other conditional probabilities. Does that help you all?
Yeah, this is just like a longer, more time consuming one compared to the other problems.
Mm-hmm. Yeah,
Yeah.
exactly. Because like I said, the ones later on, you actually have to figure out the probabilities. It's not going to be given to you. So you have to like count, figure out how many situations give you that event to figure out the probability. But once you figure that out, it's not too bad, right?
Yeah, it's just it's weird. It's weird. I don't know.
Yeah, when you think, like, I know, like, you have to like think really hard about some of them too, especially like who was I going to go over? Number 6. Like if you look at number 6 on the front, it's saying to first do it directly and then B, use conditional probability formula, the one I showed you. So like if you were to do it directly, I don't know, do you want me to go over that one?
Yeah.
How what I mean by directly versus using the formula.
Mm-hmm.
So if we look at number 6, it has this spinner, right, with the 8 numbers on it. It's like 1, 1, 2, 3, 3, 4, 4, 4, 4, and 5. And then half of these are shaded. I can't use the same color. That confuses me. Okay, this one, this one, this one, and this one. So it's saying to directly figure out the probability that the point, sorry, but let me read it. Okay, so figure out the probability that when you spin, it's going to point to an even number, given that it points to a shaded region. So with the formula, you figure out the those two, probability of A and then probability A and B, and use the formula, right? Directly. How do we do this directly? Well, you're given, what's given is that it's already pointing to a shaded region. So I'm just looking at what are the shaded regions. There's only 4, right? So now my total is actually 4, like the denominator total. Now it's saying point to an even. So of the 4 shaded ones, how many are even? Just 2 and 4. So that's 2 out of 4, which gives me a half. If I do it with the formula, I'll also get a half, because probability of B given A, the probability of A is that it's shaded, right? Because the given it's shaded. So how many of them are shaded? 4 to 8, or 1/2. And then I want to look at the probability of A and B. So it's shaded and it's even. So out of the 8, only 2 of them, right? 2 out of 8, which is a 4th. So if I use the formula, 1/4 over a half gives me 1/4 times 2 over 1, which also gives me a half. Does that make sense? So some of these you can do it directly. It's like easier with problems like this because you basically just eliminate all the other solutions and you only focus on the possibilities for the given. So the given is the given is that it's, or no, not the given. The given is that it's shaded, right? It's shaded. Which ones are shaded? 4 of them. So we're only looking at those 4. Now that's our sample space instead of all 8. That's why you can do some of these directly. Whereas other ones, like if we were doing the problems on the back, like those wouldn't be as easy directly. You have to figure out the probabilities of each in order for the conditional to be found. If that makes sense. Or it just takes more thinking. Yeah. So yeah, I hope this helped. And hopefully you can go through the ones that you were, go through the other ones and rework them so you can find the true conditional probability answer, since you have the key. Are there any other questions?
No, I'm good.
Sorry.
It's okay. Sebastian,
And,
Caroline,
I'm good.
you'll be posting the sheet with like all the problems worked out, right?
Yeah, so I don't like, it's going to be kind of like, you'll see the numerator and the denominator, and then you'll see me simplifying it. So like you'll have to know like that's like the numerator is P of A and B, and then the denominator is P of A. Like I didn't distinguish it for every single problem. But yeah, you'll see the formula, like me putting in the numbers with the formula for the problems.
Yeah, because I definitely have a better understanding of it. I just think if I could see it worked out more.
Yeah. And again, I don't have number 12 yet, so I'm gonna try to wait for that before I post it. But you'll definitely have it, like I'll post it by Friday.
Okay.
Yeah, Ms. Bird should get back to me today. So, Isai, do you have any questions?
So honestly, I don't have any questions, but like number 6,
you popped in kind of.
Which one?
Yeah, you popped in later, so I can go back. I talked about using this actual formula. So you did see like you already saw me working out some of the problems with the formula. Do you want me to like explain it a little bit more, or?
I was stuck actually like on last week. The question number 6 that asked about it was on permutations versus combination worksheet.
Okay, last week's,
So number 6, I asked about the 110 people meeting up and like their handshakes and all that. Yeah. I was kind of confused about that.
So, I did post a little key, an answer key in like a little video with a calculator help. Did you see that at all?
No.
Okay.
I think I might have not seen it. Yeah.
Okay, so I would say after this, I'm gonna go through that problem with you. But after this, definitely look at that because I wrote like the I'm trying to get to the last page. I wrote the what's it called? Like, well, I'll show you right now. But then you'll if you look at the key, you'll see the rest of them.
Yeah.
And the calculator. Hopefully, you are using your calculator for this. I don't really know. Like I know you use a scientific calculator, so maybe Google how to do it on a scientific calculator. Otherwise, I think you can also try to like. Did you end up downloading Desmos at all?
No, but like I could go like to their website and I could do it through there.
Yeah, same like with that. Yeah, exactly. So I'm gonna just go through that problem. You said the handshake one. So first, is the handshake, or for the handshake problem, is it a combination or a permutation?
It's a combination, right?
Combination, right? Because like me handshaking with you before I handshake with like Sebastian, it's still like we're still handshaking with each other, right? So it doesn't matter the order.
All right.
We just want to know how many handshakes happened. So it is combination. So this is where you have that like the big number on the left, and that's like the total total amount of people or total possibilities, right?
Yeah, I see.
To choose from.
Yeah.
Then the number on the right is how many you're pairing together, or like how many are you grouping. So for handshake, I had to think about this for a second as well. You have to think about like for handshake, how many people are you matching up for handshake?
2, right?
Yeah, no, not trick question, 2. So this is actually just 110C2.
All right.
So if you use the formula from like the 11.1 notes, that's where you have this is the formula. N over R factorial, and this is N and this is R, right? NCR. So this is how you would use this formula. But if you use your calculator, it should have this button. I showed you how to do it on the graphing calculator, and you should probably be able to find an online graphing calculator to use as well, I think, right? So it should have that. It should have this button, and you can just use the button. It does it for you, so you don't have to do the factorial calculation. But yeah, that's how this one worked. It's just because like a handshake is just 2 people, so really you're just choosing 2. It's 110 choose 2.
All right. So that makes more sense. Yeah.
Yeah. So these are like this worksheet, and all the answers were big. It was like big numbers, except for number 7, I think, was the only one that had like a small answer. But it's because you're trying to find the total number of possibilities for that scenario, right? And so there's like so many, right? So these should be big numbers, and you'll see like when you look at the key, you'll see.
All right. Yeah, that makes more sense.
Okay.
All right.
Anything else?
That's basically it. Yeah, that's the only question I had. All right.
Great.
See ya. Have a good one.
Bye.